If you draw a straight line from parts of frozen, snow-covered Canada directly across the Atlantic, you end up right in the middle of southern England. They are the exact same distance from the North Pole. Yet in the UK, you can walk down a residential street and find palm trees growing right in the front yards. This extreme difference in weather comes down to a continuously moving loop of water known as the Atlantic Meridional Overturning Circulation, or the AMOC. Think of it as a global ocean conveyor belt. The sheer volume of water it carries is difficult to picture. Every single second, this system pushes enough warm, tropical water north to fill 20 billion bathtubs. All that liquid heat warms the air above it, effectively wrapping the region in a giant thermal blanket. Without it, Northern Europe would currently be locked in an ice age climate. But as the Earth gets hotter, the very mechanism that distributes heat around the planet is breaking down. If this conveyor belt stalls completely, it triggers a chain reaction. While the rest of the globe cooks, places like the UK and Scandinavia would abruptly plunge into a deep freeze. To understand how rising surface temperatures cause freezing land temperatures, we must leave the surface entirely and look thousands of meters underwater. The engine driving this entire current relies on two things: temperature and salt. Scientists call this thermohaline circulation. This cross-section shows how the cycle begins. Down at the equator, intense sunlight heating the ocean. Because warm water is light, it floats at the surface. At the same time, this intense heat causes massive amounts of evaporation, pulling fresh water into the air and leaving the salt behind, creating a very warm, heavily salted top layer. Caught in the Earth's rotation and surface winds, this warm, salty layer is pushed north, all the way up the Atlantic toward Greenland. Once it reaches the Arctic, the freezing air strips that heat away. Now you have a massive body of water that is both freezing cold and packed with salt. That combination makes the water incredibly dense and heavy. Unable to float, this dense water plunges straight down to the seafloor, thousands of meters below. This massive sinking action acts like a drain, pulling more warm surface water up from the south to replace it. This precise difference in weight, heavy water sinking in the north and pulling light water behind it, is the engine keeping Earth's climate balanced. But rising global temperatures are throwing a wrench into this engine. Since 1992, Greenland has lost over 4 trillion tons of ice. All of this rapidly melting ice is dumping a staggering amount of fresh water straight into the North Atlantic. This diagram shows exactly why that is so dangerous. Fresh water is lighter than salt water. When it pours into the ocean, it doesn't mix well. Instead, it sits on the surface like an oil slick. This clear layer of fresh water blocks the incoming salty water from reaching the freezing air. Because the salty water can't cool down, it never gets heavy enough to sink. The underwater waterfall stalls out, and the entire ocean conveyor belt begins to grind to a halt. We can already see this happening. There is now a massive, permanent cold blob of water sitting south of Greenland, marking the exact spot where the warm current is failing to arrive. Direct measurements from sensor arrays anchored deep in the Atlantic confirm the AMOC has slowed by up to 20% since the mid-1900s. It is currently at its weakest point in over 1,000 years. The stalling of this ocean engine has moved from a theoretical computer model to a currently unfolding system failure. For decades, major climate reports suggested this system was stable enough to last through the century. But a recent shift in methodology has changed that outlook. Researchers have begun looking for early warning signals, mathematical wobbles indicating a system is losing stability. By tracking these signs, new physics-based models suggest the tipping point could arrive much sooner than expected, potentially between 2037 and 2065. If that flow of heat stops completely, the local effects would be violent and immediate. Average temperatures across Northern Europe would plummet by 3 to 10 degrees Celsius. The mild, rainy winters of the UK and Scandinavia would disappear, replaced by the frozen extremes you currently find in northern Canada or Siberia. Millions of acres of European farmland would be rendered entirely unusable. Across the ocean, North America gets a different kind of disaster. The physical force of the Gulf Stream pushes water away from the coastline. Without that force, water would slosh back, causing the U.S. East Coast to experience up to an extra meter of rapid sea level rise. At the equator, the failure of this ocean circulation severely shifts global tropical rain belts south. This would trigger massive, prolonged droughts across regions of Africa and the Amazon rainforest that rely on that rainfall for survival. The collapse of the AMOC would be a global reshuffling of Earth's entire weather system. It forces a chaotic realignment of heat, water, and air that effectively rewrites the climate of every continent on the planet. But here is the most important part of the data. The switch hasn't flipped yet. The system is weakened, but the worst-case scenario is not locked in. Because the root cause of glacial melt is human-driven warming, we know how to stop it. By rapidly cutting our greenhouse gas emissions and shifting to clean energy, we directly reduce the heat melting Greenland's ice. If we limit global temperatures, we stop the freshwater flooding. We still possess the tools and the time to keep this critical ocean engine running.